Welcome to Pre-Calculus. Today we will investigate calculating variables for continuously compounded investment. We'll take a look at two examples. Our first example is this word problem about Totsakan investing $8,184 in a savings account with a fixed annual interest rate of 8.09% compounded continuously. We're going to try to find what the account balance will be after 7 years. When you're solving a problem like this with investment, what we want to identify is how the interest is compounded. We've seen compounding at certain intervals throughout the year, but this question is presented that the account's going to be compounded continuously. And that gives us a different type of formula. If we think about continuous compounding, it's really the ultimate in growth. Our previous situations, we compounded maybe 4 times in the year, maybe monthly. If I'm compounding continuously, that's equivalent to compounding the interest at every single moment. So really, it's the ultimate in growth. Our formula for compounding continuously is as follows. It'll be some future amount A equals the principal times base E to the power of the rate times the time. So from an initial inspection, it's a simpler formula than what we would use for compounded interest at certain discrete intervals. And that's a good news for us because it makes the calculation simpler. Now we're looking for what the account balance will be after 7 years. So I just want to identify which variable would represent the account balance in the future. That's my A. So that's what I'm going to try to solve for. And I want to input values for the other variables. So the principal, the P, the rate, R, and time T. So I need to find those here in this question. I'm going to write it out. A equals, so I'm looking for the principal. That's the amount that this individual would invest at the start. And that's going to be this $8,184. That would become our P value. The base E is a number. Recall E has the value of about, well, let's see. If I type it into Desmos, it gives us this irrational number 2.718. So it's a number. I don't have to input anything for E. It's actually a value. But for rate and time, I need to find those. So the interest rate I see is given as 8.09%. I do want to convert that to a decimal. So that's equivalent to moving the decimal place 2 to the left. So that's going to be equivalent to 0.0809. I'll incorporate that into our formula. And the last variable that I need to substitute a value in is the time. And that's going to be a certain year value. We're interested in the amount in the account after 7 years. So initially, we just write an equation like the one that we've got here. A equals 8,184 times base E to the power of 0.0809 times 7. And I just want to evaluate that. We'll round to the nearest hundredth, since that would be the nearest value that would be equivalent to money, 1 cent. So we'll just input here into Desmos. Let's head over there. So we'll type in here, it's 8,184 times base E, and all you got to do is type E to the power of 0.0809 times, and you got to be sure to put parentheses around any powers where you got operations, times 7. And our estimated amount for the account at that point is $14,418.05. So you can see it's a very high growth rate. And if we think why it grows so quickly compared to compounded interest, it's because we're compounding continuously. That gives us a better, higher growth than the other type of compound interest. So again, $14,418.05. So for this example, we were just plugging in values and evaluating the equation for the future amount A. We'll take a look at a second example. Here we've got Aaliyah investing $1,299 in a savings account with a fixed annual interest rate of 6.19%, also compounded continuously. So anytime I see that word continuously, that tells me I'm using the formula A equals principal times base E to the power of the rate times the time. What we're trying to solve for here is how long will it take for the account balance to reach $2,730.25. So when I think about what I'm trying to solve in this situation, I actually know my future amount. That's $2,730.25. I know the principal, I know the rate, I do not know the time. So it presents us with a challenge because my time is in the exponent. Still, let's set it up by substituting in values. So again, for my A, my future amount, that's $2,730.25. The initial investment's going to be the $1,299. And if there's any question, it should be the smaller of the two values since we are looking for growth. Base E is always what it is, again, a value of about 2.71 to the power of the rate. So I see my rate here is 6.19%. As a decimal, that'd be 0.0619. Always want to put the rate as a decimal instead of a percentage, and then we'll leave time as a variable since that's what I'm looking for. So different from our first example, here I want to solve that equation to find the time. Somehow I have to access the time that's in the power. Let's first of all isolate this base E to the power of 0.0619t. That's what we want to get by itself first. So I need to cancel 1,299. Since it's connected by multiplication, I'll divide. And with a question like this, I don't want to do any intermediate calculations. I just want to build up an expression on the left side that I can type in all at once. So for my next step, I'm not going to actually divide here on the left. I'll just record $2,730.25 over $1,299. And that now equals base E to the power of 0.0619t. So in terms of our intermediate steps, we've gotten that base E to the power isolated. Now we do that so that I can take the power down. Now I want to use one of my strategies that involves a logarithm. Now since my base is E, the logarithm base that I want to apply to both sides will be logarithm base E. And remember, that's equivalent to natural log, which is given by ln. That's my log base E. I'm going to apply it to both sides. And what happens is this is going to, by my power property of logarithms, take this rate times time, which is currently an exponent, and bring it out in front of the logarithm as a coefficient. So my next step, again, I'm building this left side up, is natural logarithm of the fraction 2,730.25 over 1,299. That now equals 0.0619t times the natural log of E. So we're one step away from the solution, maybe 1.5 steps. What we need to think about is what's the value of natural log of E. So remember, that's really equivalent to log base E of E. So if I'm trying to evaluate that expression, remember the exponential would be E to some power equals the argument E. And if I'm raising something to a power and getting the same thing back, there's only one number that would do that, and it's the power of 1. So in fact, natural log of E becomes simply 1, and in a way just vanishes. So all I've got on this right side is simply 0.0619t. And to finalize the solution here, that's what I'm going to divide by. And that finalizes this expression on the left side. All I need to do is take that natural log of the fraction 2,730.25 over the initial investment of 1,299, all divided by the interest rate 0.0619. And that should give me my time. So we'll head over to the calculator to crunch that time value. So we're going to start with a fraction. Natural log is in the numerator, and then a fraction with my future amount, $2,730.25 over the initial investment, $1,299, over the interest rate 0.0619. And we got a decimal value here that's 11.99997 and so forth. We'll round to 12. So ultimately what we've calculated here is that it will take 12 years for Aaliyah's account to grow from the initial $1,299 to $2,730.25, 12 years. So definitely when we're trying to solve for either the interest rate or the time, we have to do more equation solving. But with the help of logarithms, it's really quite straightforward. Thanks for joining for these 2 examples on calculating variables in continuously compounded interest. See you soon.